Hello guys and welcome back to this new video. Today I'm implementing a linked list using LIFO concepts. What this means is if the inserted elements are 1, 2, 3, 4, 5 in this order, the linked list will be in this shape. At the top of the list we will have the last element. This is what this means: last in, first out. The last element that we insert is gonna be the first element in the list, and the first element will be at the last. So let's get started. We will declare the structure first. Yes, it's gonna be node int data select. This is gonna be create list. Oh wait, first it's gonna be equal to null, then for it's I equal to 0 is less than 10 and I our function here. If we displayed our list, it should be working. So it's gonna take 5 elements. 1, 2. In the same order. We're gonna create some helping functions like add element at the top and add elements at the end. And I forgot the most important one, free list, which is gonna take our lists. So node currently while h is different than null. Free. Read successfully. List. So let's try it now. Freed successfully. Now void top. It's gonna take our list and a value. If new node null unable to allocate space return. This is a double pointer. So to test it, give the address of the list, and then we give an element, let's say 10, and gonna display it again. So let's test it. It added the value 10 at the top of our list. gonna give a position or an index to the place where you want to put this element, in the second index or the third or wherever you want. Sorry. So new element, new node equals the index minus 1 and is different than null. So what we're doing here, first we allocated a space for the new element, then we give it the value, and then next it points to null. Then we created another variable node and took the value of the head of our list, and we're gonna go through each element until we get to the index that we want. Here it's index minus 1 because we want we're gonna put the value inside the index, which means we're gonna go through each element before that index. So when we get to this index, we stop. So current dot next, and here the position, the index, can be out of range, can go until it gets to null. So here, if current is equal to null, I'm gonna print index out of range. Here, new node equals current next. Current dot next is equal to new node. So we have our own list. So we have the list and we have the elements. We're gonna divide our list like here. We have this list. We want to add the element 7. Alright, in the third position, first we're gonna first element, second element. Here, this is the third element. This is the third position. So we go to the index -1 to the second index, then we make it point to 7. We're gonna link it to 7, and 7 will link to this, to the second element dot next. So if you know what I mean, if you understand. So our new node dot next will point to the current dot next, and the current dot next will point to our node. Now let's implement it to see if it works. Add element in the middle. Gonna add the element 7 in the third position. Then we display. We're gonna delete this. First, our normal list, and then in the third position so the 0 indexed first, second. When it gets to the third, it will point to this element, and this element will point to the next element. Now inserting at the end. Gonna copy and paste. Next will be equal to new node. This should be the easiest. Add elements at the end. This is our normal list. and here it added the 10 elements, 10 at the last position or at the end. So that's for today's video. Hope you learned something new. See you in the next one.